Welcome to day 4 of our summer tutorial. I know you have been enjoying the classes. Today we are going to thermometric substances, thermometric calculations. I'm going to show you how to solve problems on thermometric calculations. You don't need to cram any formula. Just follow what I'm going to show you. Please watch this video to the end, follow the steps, and then try the exercises, the community practice questions at the end of the class. Go to the community section and vote. Please vote for your answer. Okay, let's go straight into this. Welcome to today's class. Just know that let this be the Celsius, let this be for Kelvin, and let this be for Fahrenheit. The three different units for temperature: Celsius, Kelvin, and Fahrenheit. And then you have to know that we have this is the ice point. This is the ice point. That's the lower fixed point. This is the upper fixed point or steam point for pure boiling water. And then the lower fixed point or ice point. Then note that for Celsius temperature, this is 0 degrees C and this is 100 Celsius. That's for low ice point and the steam point. You can have it as lower fixed point and upper fixed point. Then for Kelvin, we have it to be 273 Kelvin or 373 Kelvin. And then for Fahrenheit, we have 32 degrees Fahrenheit or 212 degrees Fahrenheit. Just know the ice point and the steam point. Any other thing in between it is called fundamental interval. Any other thing in between it, that's the fundamental interval. Fundamental interval. Fundamental interval. So anything in between it is the fundamental interval. Now let's look at how to apply this in solving calculations. The first one, a temperature scale has an upper fixed point of 260 millimeters and a lower fixed point of 60 millimeters. What will be the reading on this scale when a thermometer reads 125 degrees Fahrenheit? In this particular case, we are comparing the temperature scale in millimeters with that of Fahrenheit from the question. So remember that the lower fixed point is 32 and upper fixed point for Fahrenheit scale is 212 degrees Fahrenheit. Okay, let me keep the units up. Okay, remember the question said a temperature scale has an upper fixed point of 260 millimeters. That means we have 260 millimeters for that particular one. And the lower fixed point is 50 millimeters. So what will be the reading on the scale when a thermometer reads 125? When a thermometer reads 125, what will be? We'll use X. We want to find the reading on that when the Fahrenheit scale reads 125. Once you measure it like this, how will you solve this thing? You are comparing this with this. So look at what you are going to do. The unknown Compare this place to this place. That's x minus 50. X minus 50 over the upper fixed point, 260 minus 50. 260 minus 50. That is for this scale. Now repeat the same thing for the Fahrenheit scale. Is equal to, because you can solve this problem by comparing this with this. X minus 50, 125 minus 32, because this and this goes, this and this goes. Then 260 minus 50, 212 minus 32. This is how to solve this problem. So we have x minus 50 over 210 is equal to 125 minus 32. That's 93 minus 212 minus 32. That will give us. So we'll go ahead and solve this. 180 into x minus 50 cross multiply is equal to 210 times 93. We'll go ahead and open the bracket. 180x minus 9,000 is equal to, if we multiply this, we'll have 19530. So we'll go ahead and collect like terms. 19530. This one moving plus 9,000. That will give us so x will be, we'll get our final answer as 158.5 millimeters. This is how to solve this problem. The second example, let's take it from resistance thermometers. A resistance thermometer has a resistance of 10 ohms at 0 degrees Celsius and 70 ohms at 100 degrees Celsius. If it records 55 ohms in a starting medium, calculate the temperature of the medium. Okay, remember how we do it? We are comparing a resistance thermometer in ohms with Celsius. Okay, in this case, remember that the lower, since it's degrees Celsius, we'll have 0 degrees and 100 degrees Celsius. Then for the ohms, we have a resistance thermometer has a resistance of 10 ohms at 0. We have 10 ohms and 70 ohms at 100 degrees Celsius. If it records 55, if this records 55 ohms at a certain temperature, we don't know, let's put x at the unknown section. Calculate the temperature of the medium. Remember the way we did the other one? We'll compare this first and say 55 minus 10 over 70, that's up here. 70 minus 10 is equal to the same thing you do it to the other one. X minus 0, the other side, 100 minus 0. So this will give us 45 over 60 is equal to x over 100. If we cross multiply, 60x is equal to 45 times 100. So that x will be over 60. Then we'll have our final answer to be 75 degrees C. Thank you for watching to this point. Please look at the community exercise. Try it and go and vote for your answer. Remember to share this video, like, and if you have not subscribed, please do well to subscribe to this channel. See you in the next class. Thank you.